Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, SET exam, PhD exam, TIFR, Jest, IIT-Jam exam and other exams related to physical science. And my courses are absolutely free of charges, so anyone can watch and and my courses are going to help them to crack the exams related to physical science. Okay, so this is the lecture number 8 of mathematical physics. We are discussing a Dirac delta function here. This is the part third of Dirac delta function. Here we are going to solve questions related to Dirac delta function. Okay, and I apologize because last time my class was ended automatically, so that's why I'm starting again. Okay, so I'm going to start. So I'm going to start with first question, which is asked in CSIR NET 2023, and also this question is asked in Jest. Okay, so I'll start. So question is, you need to find out I equal to integration minus infinity to plus infinity e to the power minus mod x upon pi, e to the power minus mod x upon pi, and then delta sin x. Okay, delta sin x dx. So this is the question, and we need to find we need to integrate it. Okay, so it's a question related to Dirac delta. Okay, so we're going to start. So this is the one this. Okay, so I have already explained the property number 8 of Dirac 18 of Dirac delta function, right? This is, that is delta fx, Dirac delta of any function, that is going to be equal to sigma I 1 upon f dash xi mod delta x minus xi, right? This I have already discussed. We'll use this property and solve this question. So this is the question. Okay, so this is going to be delta. I have already explained this question, the value of delta sin x, right? And I also told you that you can memorize it as a formula. Okay, but here I'm going to solve it. Okay, so then you can easily solve this question. It will reduce your steps. Okay, so this is delta sin x is going to be sigma I 1 upon f dash x, means sin function is f sin x. Okay, this is sin x. Okay, so it's integration, that is differentiation of sin x is going to be cos x is cos xi, using this formula. Okay, this one cos I mod delta x minus xi. Okay, this is the one. So we'll solve further. So it is going to be del sin x, del sin x, del sin x is going to be sigma I cos mod cos xi, and this then this is going to be, first we'll find out xi, right? Xi. For finding xi, that is the roots of function. That is, for finding this, what we do is we put function equal to 0, and replace x by sin xi. Sin xi is going to be 0 space, so this is going to be sin xi is going to be equal to sin the 0, the value of 0 is sin n pi, right? That implies xi is going to be n pi. Okay, now we'll put the value. So this is delta sin x. Delta sin x is going to be sigma n 1 upon cos n pi will place value, or will put the value of xi, okay, cos n pi, and delta x minus xi. Okay, this is the value. Now we'll put this value here. This is going to be, so this is the value. So now I is going to be, this is the I, right? This one, we'll put this value, and in place of delta sin x dx, sin x, we'll put this value. Okay, so it is going to be integration minus infinity to plus infinity, minus infinity to plus infinity, e to the power minus mod x upon pi, e to the power minus mod x upon pi. This is value is going to be sigma n 1 upon cos n pi mod. Okay, this is mod and delta x minus x, okay, and dx, right? So this is going to be, and we have already solved value of this, but here we'll do it again, and where the value of n is 0, plus minus 1, plus minus 2, comma, plus minus 3, so on. That is minus infinity to plus infinity. Okay, this is the one. Now I is going to be minus infinity to plus infinity, e to the power minus mod x upon pi. This we will write the value, right? This is going to be, so this value is minus infinity to plus infinity, right? So we'll put these values from minus into plus infinity. So we'll write minus 1, so this is going to minus 2, this is going to be 1 upon cos n equal to minus 2, means minus 2 pi, okay, delta x minus minus 2 pi, right, plus we'll write x equal to minus 1, n equal to minus 1, so it is going to be 1 upon cos minus pi mod. Okay, this is mod, delta x minus minus pi. Okay, next phase, this is going to be plus, then pi equal to n equal to 0. We'll put n equal to 0, so it's going to be cos 0 mod delta x minus 0, right? When then we'll put in this here n equal to plus 1, so it is going to be 1 upon So putting value here, right? This 1 upon cos n equal to 1. So 1 upon cos pi mod plus, now we'll put n equal to plus 2. This is going to be 1 upon cos 2 pi mod, okay, and delta x minus 2 pi. Here it is going to be delta x minus pi, right? X minus pi plus so on, because the values are plus minus 1, 0, plus minus 1, plus minus 2, so on, right? So these are the values we have put. This from minus infinity to plus infinity. So in between we have put the value here n equal to minus 2, here n equal to minus 1, here n equal to 0, then n equal to 1, and n equal to 2. Okay. So this then I is going to be integration 0 minus infinity to plus infinity e to the power minus pi mod upon pi x of mod x minus mod x upon pi, and these values, right? Always okay, it's cos minus theta is theta, right? So this is going to be cos minus 2 pi. Value of cos this is cos minus 2 pi is cos 2 pi, right? We know here, right? This one cos 2 pi, value of cos, sorry, this one is going to be like cos minus theta is going to be cos theta, right? We know from trigonometry. So it is going to be the same, right? Cos 2 pi is cos minus 2 theta, 2 pi is cos 2 pi, and value of cos 2 pi is 1, and mod is there, so value is going to be 1 here, right? And similarly, and this is going to be pi plus x plus 2 pi, and here cos minus pi is cos pi, value of cos pi is minus 1, but there is a mod, so value is going to be 1. Similarly, cos 0, cos pi, cos 2 pi mod, these values are 1. Okay, we'll put the value now. This is going to be first one, this one. So cos delta x plus 2 pi, delta x plus 2 pi plus delta x plus pi, this one x plus pi, okay, because delta x minus pi is minus plus x plus pi, okay, x plus pi plus delta x, this one x minus 0, that is x plus delta x minus pi plus delta x plus pi, okay. These are the values. Now we'll put the values. So now we can write it like this, minus infinity plus infinity, okay. So this one, now we are going to put the value, okay. So this is going to be minus infinity to plus infinity, these values. We'll put these values, so these are going to be this one. This is okay, so it's going to be if you put this value, so it is going to be e to the power minus infinity plus infinity. This first we will write, this is going to be delta x plus minus infinity to plus infinity, this is going to be delta x minus pi plus minus infinity to plus infinity delta x plus pi. Okay, we'll write in this order. Okay, and this is going to be minus infinity to plus infinity delta x uh, x plus pi, so x plus x minus 2 pi x minus 2 pi into delta x. Okay, x plus 2 pi dx, here also dx, here also dx, this is also dx. Okay, plus integration minus infinity to plus infinity delta x plus 2 pi dx plus so on. We can write in this order as well. Okay. These are very important questions, guys. Okay, this question is asked in Jest as well as NET 2023. So it's x plus 2 pi. Okay, now it is going to be I equal to, so here and e to the power we have missed this term, e to the power minus mod x upon pi. Here also e to the power minus mod x upon pi. Okay, here also e to the power minus x upon pi. In here I'm going to write again, so we have missed this one. Okay, okay guys, I'm going to write it again. So it is going to be minus infinity to plus infinity. So we are writing these together, and then this one we can write in this order as well. Okay, so it is going to be e to the power minus mod x upon pi. Okay, mod x upon pi delta x. Okay, plus e to the power minus infinity to plus infinity delta, sorry, it is going to be e to the power minus x mod x upon pi. Okay, and delta x minus pi plus e to the power minus infinity to plus infinity e to the power minus mod x upon pi delta x plus pi. Okay, plus integration minus infinity to plus infinity e to the power minus x mod upon pi delta x minus 2 pi plus minus integration minus infinity to plus infinity e to the power minus x upon pi delta x plus 2 pi plus so on. Okay, this one. Now we'll solve it. Okay, so this is the one, right? X minus 0. So this here we'll put the value of x, because here x minus 0, delta x minus 0, right? You can write delta x also, delta x minus 0, and I think it is better to write x minus 0 because then it will be easy to use Dirac delta property, right? So here we'll put the value. So the value of a is 0, right? We know the integration of this a is fa, right? So this is the function. E to the power 0 is going to be 1, and 0 is between minus infinity to plus infinity, so it's going to be 1 plus, we'll solve this one. So this is going to be this second term, right? This is x equal to x minus pi. So value of value of a is pi, right? We'll put here value, because the we'll put pi here, and we know the value, this is mod x, right? So the value of pi is going to be pi only. Pi get cancelled, so it is going to be e to the power minus 1. Okay, e to the power minus 1 plus this is also going to be e to the power minus 1 plus this is going to be e to the power minus 2 plus e to the power minus 2 plus so on. Okay, these values, this if we integrate this using Dirac delta property, right? So this is going to be, because mod x, value of mod x is going to be positive always, right? So we will, if you put mod pi, so that is going to give value pi. Similarly here, right? So which property we have used here, I'm going to write as well. So we have used, that is minus infinity to plus infinity fx delta x minus a, right? This value we know, that is fa, right? Using this property, uh, in this we've got these values. I hope you understood, guys, right? This property I have already explained. Well, so these are the values. So these are going to be 1. Here we can take e to the power here. Okay, so this is going to be, these will get added, right? So this is going to be 2. Okay, 2 will 2 e to the power minus 1 plus 2 e to the power minus 2. Okay, plus so on. So value of I is going to be 1 plus, here we'll take 2 common, so it is going to be e to the power minus 1 plus e to the power minus 2 plus so on, right? Here what we can do is, here 1 plus 2, we can add 1 and add 1 in this expression and subtract 1, so that is not going to change this expression, right? So we can write e to the power 1 plus, we have added 1, e to the power minus 1 plus e to the power minus 2 plus so on, and minus 1 we have subtracted, right? So this is not going to change the expression, so it is going to be I equal to 1. And in next class, there is one more lecture is remaining regarding this Dirac delta function or vector analysis, and after that we are going to start matrix. Okay, it is going to 1 plus 2, and this we know, right? Geometrical series. So this is going to be 1 upon 1 minus r, right? It is going to be 1 upon 1 minus e to the power minus 1. Okay, minus 1. This we know, right? It's like 1 plus x square, x plus x square. This expression, I'll write it for you so that it will be. These questions are very important, so that's why I'm writing it stepwise. I'm not skipping any steps, right? So that it will make it clear to you. Okay. This is 1 plus x square plus so on. If this is the series, then there's a formula that is 1 upon 1 minus x. This is the one, right? This formula we used here. Here x is e to the power minus 1, right? Okay, so this is the one. Next it's going to be I equal to, this is going to be 1 plus 2 into 1 upon, this we can write 1 minus 1 upon e, right? Because this is e to the power minus 1, right? It is minus 1. We'll solve it. This is going to 1 into 2, this 1, this is going to be E upon E minus 1 minus 1. Okay, so this is going to be 1 plus 2, 2E upon E minus 1 minus 2. Okay, this is the one. Now we'll solve it. So it is 1 plus, we'll solve it. Okay, so this is going to be 2E minus this one is going to be minus 2E plus 2 upon E minus 1, right? So that is going to be 1 plus 2E plus 2. Okay, so this is only for this. Okay, 2, this is only for this 2. No, just wait. It is the 1 minus 2 minus 1. Okay, okay, so this is the 1 2. Just let me check. Okay, this will get cancelled. Okay, so it is going to be 2 upon E plus 1, right? This is minus 2, this is minus 2, and then we'll solve it. So it's going to be, this is minus, this is just a calculation part, guys. Okay, it is going to be E plus 1 minus 2 upon E plus 1. So it is going to be E minus 1 upon E plus 1. Okay, this is the 1, E minus 1. Okay, this is the answer. Next question. Okay, just let me check if there is any mistake. Here I think this one. So just let me do it again. What calculation mistake you have done? Let me just check. This one is this 2E. This is going to be 2E into E minus 1. This one gets affected. This is going to be 1, right? So now we'll solve it. This is going to be 2E minus E plus 1 upon E minus 1. Okay, so this is going to be E plus 1 upon E minus 1. Yeah, this is the correct answer, guys. Little bit mistake in calculation. Okay, so this is the answer, guys. Very important question. So now you know we have just used this property, guys. I'll show you that property number 18, which I have already explained, right? This property we have used, this one. Okay, well, this is very important question, guys, and I hope you understood this question. So now we are going to solve next question. Next question is also a very important question. So next question, question number 2. Okay, so this is also important question, and this is asked in CSIR net June 2019. Okay, very important question. This is also related to the delta function, and using property number 18, which I have already explained, right? We'll solve it. So question is, I'll write the question, that is you need to find I equal to minus infinity minus pi by 2 to plus pi by 2, okay, dx into minus 1 to plus 1 dy delta sine 2x into delta x minus y, okay, and this you need to find out, okay. The value of I is minus pi by 2 to plus pi by 2 dx minus 1 to plus 1 dy del sine 2x into del x minus y, okay. So this you need to find solve, okay. So I'm going to solve it for you. So this is going to be, and again we'll use this property, okay. So I is going to be, we can write this like this, minus 1 to plus 1, okay, and this is dy minus 1 to plus 1, and this is dy, okay, and we can write minus pi by 2 to pi by 2 pi by 2 pi by 2, and this is going to be del sine 2x into del x minus y, okay, and dx outside, right. We can write this expression like this as well, okay. So limit minus 1 to plus 1 dy minus integration minus pi by 2 to plus pi by 2 delta sine 2x del x minus 1 dy, right. So this is going to be I equal to minus 1 to plus 1 dy, that is integration minus 1 to plus 1 dy, and this is going to be, here we'll use the property, guys, okay. So we know this property number 8, right, which is minus infinity to plus infinity fx del x minus a, right. This is going to be very important step, guys. This is going to be fa. This is going to be fa, right. This we know, this property. So we are using to this property. The value of y is between pi by 2 to minus pi by 2 to plus pi by 2, okay. So this one, this is the this will take as a function, that is fx, okay. So then this value is going to be, sine 2y, because fa a is y here, right, sine del sine 2y, right, dx. This is the one, right? It's very important step. This dy not, this is just fa, right. Fa is this del sine 2x is fx here, right, guys, okay. So this x minus y is between minus pi by 2 to pi, so this is going to be del sine x will replace x by y, like fa. I hope you understood, right. This is very important step. Now we can easily solve it, okay. So this is the one, okay. So now this expression is going to be minus 1 to plus 1 sine del sine 2y, okay, dy, this one, okay, del sine 2y dy. Now we'll use this property number 18, we know, right. So we're going to solve it. The property number 18 is, since we know, I'm going to write it. We should write every time, so that we can learn it, and it can get memorized, okay. So this is going to be, this property number 18 is integration minus infinity, this one, sorry, property 18 is del of del fx Okay, Dirac delta of any function is going to be sigma I 1 upon f dash xi mod del x minus xi. Okay, very important property. So we'll use here. This is going to be I. Here we'll use minus 1 to plus 1 sigma, but before that we'll find value of xi. Okay, xi. So for xi is the root of the function, and finding root of function, what we need to do is we need to do sine 2y 2yi. This is because here y is there, right? So it is going to be 2iy uh, is going to be 0, right? So this is going to be sine 2yi going to be sine n pi n pi n pi n pi. That implies yi is going to be n pi by 2. Okay, and where n equal to 0 plus minus 1 plus minus 2, so on. Okay, next is going to be, we'll write here the value. So it is going to be minus 1 to plus 1. Okay, dy, this is dy. Okay, so dy, I can type dy later. So it is going to be sigma I sigma n 1 upon this value will write here. Okay, so let's first write this value, then we'll value of delta sine 2y. Delta sine 2y is going to be sigma n delta sigma n 1 upon sine 2 pi differential is going to be 2 cos n pi mod and delta y minus y minus yi. Okay, this is the value, because yi equal to this, we'll put the value here, right? Different will 1 upon f dash xi. Here xi, in place of xi we have y, right? So this is going to be the difference, this sin y, the differentiation of sin y is going to be 2 into cos y, cos 2y mod, and the value of yi is n pi by 2, right? So this is n 2 into 2 n pi by 2. So that is going to be 2 n pi. Okay, like this, cos 2 y is there, yi is n pi by 2. 2 get cancelled, this will become n pi. Okay, so this is the value. Now we'll put the value here, right? This integration one. So it is going to be integration I equal to integration minus 1 to plus 1. Okay, and the value of this one, this delta sine 2y. So this is going to be sigma n into 1 upon 2 cos n pi mod, okay, delta y minus yi dy. Okay, so now this is going to the 2 mod 2 is 2, we'll take that outside. So this is going to be 1 upon 2 and integration minus 1 to plus 1, and value of n is plus 0 plus minus 1 plus minus 2, so on to infinity, right? Plus minus infinity. So it is going to be 1 upon cos n pi mod delta y minus yi dy. Okay, this is the one. Next step is going to be I equal to we'll put the value. Okay, so this is going to be minus 1 to plus 1. Here we'll put the value. Okay, so we'll first put n equal to 0. So in n equal to 0 it is going to be 1 upon cos n pi. Cos n pi, n pi is cos 0, cos 0 is 1. Okay, I'll write it, that would be better. It is going to be 1 upon cos 0 mod and then delta x minus 0. Okay, this is the one. Plus, now we'll put n equal to minus 1. So it is 1 upon cos n pi minus pi mod delta x minus pi. Okay, and here just wait, the n value of n is n pi by 2. Yeah, this is n pi by 2. It's n pi by 2. N pi by 2. So yi in place of this n pi by 2 we are going to write y is n pi by 2. Okay, here it became n pi because 2 into n pi by 2, 2 get cancelled, right? So this is n pi, so pi by 2, this is pi by 2, n pi, n equal to minus 1, right? N pi by 2, so minus 1 plus 1 upon cos, now n equal to 1, so that is going to be pi, cos pi mod and delta x minus pi by 2. Yi is n pi by 2. Okay, so n equal to 1 means pi by 2. I hope you understood it right. Okay, this is next. Okay, n equal to 2. This is going to be cos minus 2 pi. Okay, n equal to minus 2. We'll take it. So it is minus 2 pi mod and delta x minus 2 pi. Okay, plus 1 upon cos minus pi, cos n equal to 2 will put. Okay, so n cos 2 pi mod. Okay, and delta x minus 2 pi plus 1. We have put n equal to 0, n equal to minus 1, n equal to plus 1, n equal to minus 2, n equal to plus 2 plus 1, right? So this is going to be I equal to it is going to be minus 1 to plus 1. Okay, so this is going to be cos 0 is 1, and these values cos pi, cos minus pi, cos 2 pi, these values are going to be 1 because mod is outside, right? These I have explained many times. Okay, so it is going to be delta. In my previous lectures I have explained, I explained many times. Okay, so this is going to be del x minus 0 plus del this is one, del x minus 0 plus del plus pi by 2 plus del is going to be del x minus pi by x plus pi by 2, this one, plus del x minus pi by 2. Okay, plus del x minus this 2 pi by 2. Okay, 2 pi by 2. Okay, this is 2 pi by 2 plus del x minus, this is plus. Okay, this is going to be minus 2 pi by 2. plus so on. These are the values, okay, into dy, okay. This is the one. So now we are going to write it like I equal to this is going to be minus 1 to plus 1 del x minus 0 plus 1 by 2 is outside, okay. That 1 by 2 is outside. 1 by 2 is outside. 1 by 2 is outside. So this is going to be this plus integration minus 1 to plus 1 delta x minus x plus pi by 2 plus minus 1 to plus 1 delta x minus pi by 2 plus so on. Now we can see that this is I is going to be the pi. The value of 0 is between this one, right? And is there any other thing we are missing? No. Okay. Yeah. So we can see that this value is going to be minus 1 to plus 1. This value is going to be 1 by 2 into 1, and these values are going to be 0 because x minus pi by 2, right? Minus pi by 2. Pi by 2 is doesn't come between minus 1 to plus 1, or minus pi by 2 doesn't come between minus 1 to plus 1, right? So this means these values are going to be 0. So value of I equal to 1 by 2. This is the answer, guys. Very important question, okay, and asked in Jest and NEET both examinations, okay. Well, we are going to solve next question. Question number 3rd, okay. Okay. Question number 3rd is, this is also this question is also asked in Jest, okay. Very good question and simple one. So this is, you need to find out value of I equal to 100 root 2 100 root 2 upon pi 100 root 2 upon pi integration 0 to pi by 2 0 to pi by 2 x delta 2 sin x minus root 2 dx, okay. This is the one. I equal to 100 root 2 upon pi 0 to pi by 2 x, and x delta 2 sin x minus root 2 upon root 2 minus 2 sin x minus root 2, okay. This is the question. So we will solve it, okay. I'm going to solve it now. 1 upon root 2 upon pi, okay. So this is going to be 0 to pi by 2 x, and here what we are going to do is del 2 will take as a common. This is going to be sin x minus root 2 upon 2 it will be, right? So root 2 upon 2 is going to be, if we solve it, this is going to be 1 upon root 2 1 upon root 2 1 upon root 2, okay, 1 upon root 2 dx. Now we know this property, right? I'll write it for you. So the property of the Dirac delta, that is delta kx, okay. This is going to be, k is constant, right? 1 upon mod k delta x, right? This property also I have explained. So we are going to use this property, okay. So this is going to be 100 root 2 upon pi 0 to pi by 2 x, and this is going to be 1 upon mod 2, 1 upon mod 2, and this is going to be delta sin x minus 1 upon root dx. Okay, this value is going to be 100 root 2 upon pi, right? So this is the one. Now this is delta sin x minus root 2. Okay, well, so this is the one. So here also we'll find out this value. So let's find the value of delta sin x minus root 2 first. Okay, we'll find, it's a function, right? This is delta sin x minus 1 upon root 2. Okay, this we know, right? You will use the property of Dirac delta function. That is 18 property. I'm writing it again. That is del of fx. The function of fx is the fx is this here. Okay, this is going to be sigma I 1 upon f dash x xi mod del x minus xi, right? This is the property. So we'll use this property here. So it is going to be del sin x minus 1 upon root 2. This is going to be sigma, and this is going to be, first we will find out the root. Okay, root. For finding root, what we do is we'll put function equal to 0, replacing x by minus x by xi. Okay, so it is going to be sin xi 1 upon root 2 is going to be 0, right? It means sin xi is going to be 1 upon root 2, and 1 upon root 2 value is sin pi by 2, right? Sorry, pi by 4 cos sin 45, right? Pi by 4. So it means value of xi is going to be pi by 4. Okay, now we'll put this value. So this is going to be the value of del sin x minus 1 upon root 2. This value is going to be, this one, value of this xi, right? This is going to be sigma n, sigma I, you can say. Okay, sigma I, and 1 upon, will differentiate it. It is going to be sine, differentiation of sine is cos xi is pi by 4, right? Cos pi by 4. This is constant. The differentiation of constant is 0 mod pi by 4 into delta x minus pi by 4. Okay, x minus pi by 4. Now we put the value. So this value, so now the integration is going to be I equal to 100 root 2 upon pi 0 to pi by 2, 0 to pi by 2, 0 to pi by 2, and this is going to be sigma, the value of this del sin x minus root 2, right? Sin x minus root 2. So this is 2 is outside, right? This 2 mod 2 we have taken outside, this one. this we take outside, right? So this is going to be sigma I 1 upon cos mod cos pi by 4. This is 1 upon root 2. This is also mod, okay, and this is going to be del x minus pi by 4, okay. This is the one, and x is also here, x, right? Okay, so this is going to be I equal to, now this is going to be 100 root 2 upon 2 pi, and root 2 will come, they will go here, right? Mod 1 upon mod root 2 is 1 upon root 2, okay. So this is root 2 into integration 0 to pi by 2 x del x minus pi by 4, right? Okay, so 2 root 2 will get cancelled with 2, okay. Here we'll use this property, the property number 8, that is minus infinity to plus infinity, fx del x minus a is going to be fa, right? This property we know. So this is going to be 100 upon pi into, this is going to be, because pi by 4 is between 0 to pi by 2, right? So this is going to be pi by 4. Pi will get cancelled, and that is going to be 25. Okay, this is the answer, guys, because pi by 4 is between this. Okay, so this is the answer. So this question is asked in Jest. Okay, guys, so these three, so I taught 3 lectures of Dirac delta function, and I covered almost all questions, all types of questions of Dirac delta function, which you will get in uh, examination related to physical science, okay. And so I would request you practice these questions and revise it. And so, guys, today I'm going to stop here. There is one more lecture of vector analysis, so we'll solve some properties of that vector and vector product and cross product related to Laplace equation, right? Related to del. So that's what I will teach you in next class. Okay, so as of now I'm going to stop here, and also I would request the people who haven't subscribed my channel, please subscribe my channel and watch my lectures, which are absolutely free of charges, and my lectures are going to help you all the examinations related to physical science. Okay, okay, guys, thank you so much. Bye now.